All right, I think this might be my last graph. So where is this carbon dioxide coming from? And I kind of mentioned this before when we talked about fossil fuels in our last unit video. I talked about that, hey, things that have carbon in them, you burn them, you're going to get carbon, at least in an atmospheric form, so in this case carbon dioxide. Here's an actual breakdown of when I say it's coming from fossil fuels. This graph is showing you how it has changed over time based on different sectors. So if we take a look at energy, this is referring to energy in our homes. This is includes heating. It also includes industry. So it's including quite a few different fields, but any kind of energy or really electricity production. This is what the majority of our carbon dioxide is being released from. So it's different fossil fuels. This can be fossil fuels such as coal and natural gas. Those are kind of our two main ones where our energy is coming from. And as you can see, this blue section is actually increasing over time, showing us that, okay, the energy sector is growing, and that's where more and more of our carbon dioxide is coming from. Now, the way to read this graph, this agriculture and land use, the way you read this is looking at just the green area. So the green area is not like 16 million. The green area is from this to this, which looking at this scale looks like it'd be about 3 million. So energy is the biggest wedge. You can also see is that as you move along, this agriculture is actually getting smaller. So it's becoming less of a source of carbon dioxide. Here's transportation. Transportation is very, very slowly growing. Same with industry. And it looks like kind of all this other stuff, residential, commercial, other things, has kind of been constant over time. So our biggest issue is actually energy use. But again, this is all coming from fossil fuels, and I will say wood as well. Remember, you burn wood, wood is made of carbon. You burn that carbon, you're going to get carbon dioxide. So this is one source of our carbon dioxide. Another source of our carbon dioxide is removing our forests. But I really want to emphasize removing our forests and not replanting them. Remember that trees are a renewable resource. If we cut down the entire forest, or even if we cut down half the forest, those trees will come back. They'll grow back. If we replant a forest, that's more trees. The issue is when we plant trees and then don't replant them. And there's actually two reasons why this is an issue. One, think about the process trees do. Trees photosynthesize. So as a recap, photosynthesis is carbon dioxide plus water plus sun. And that's going to get us a sugar. So we talked about glucose, but just sugar in general. And it's going to give us oxygen. Well, you get rid of those trees and you don't replant them, you just got rid of a mechanism that's taking in carbon dioxide from the atmosphere. Well, we should replant our trees then. We want to keep taking that carbon dioxide out of the atmosphere. So that's one issue. The other issue is that when you cut down those trees, more than likely you're using machinery that's using oil, that's using gasoline. You're also probably using those trees for some sort of function. Maybe you're processing them to turn them into planks. Maybe you're turning them into pencils, into paper, into whatever. And all of those processes take energy. So no matter what you're doing with those trees, unless you're using that tree as a log and for a log cabin, you're treating that tree some way or another. And that's going to use carbon dioxide as well, because there's going to be energy, there's going to be fuel, there's going to be fossil fuels that are fueling that process. So there's actually two ways removing our forests can affect that amount of carbon dioxide in our atmosphere. Now, although there are tons of different greenhouse gases, the only two that we're really going to explore in this class are carbon dioxide, because that's the one that's been increasing over the past, few decades, and it's also the one that we have the most of. We'll also take a look at methane, because it is the second most one, and is fairly potent, so about 28 times more potent than carbon dioxide. And this is actually something that you and I could really change. Some of those other greenhouse gases we can't really change that much, because it's not we, as in you and me, it's not really us that are causing those. It's more of industry. So methane is our second most released greenhouse gas. And methane is released through a special process referred to as anaerobic respiration. So this word, if I were to break down this word, an means not, and aerobic refers to using oxygen. Now, we've talked about respiration in this class before. We've talked about cellular respiration. And when we talk about cellular respiration is a type of aerobic respiration, which should make sense because aerobic means with oxygen, and we know that cellular respiration needs oxygen. So here, this is a recap from before. This is a recap of what cellular respiration or aerobic respiration is. You and I, we have to breathe in oxygen. We've got to eat sugars. We have to eat food. And because of those two processes, we exhale carbon dioxide, we pee out water, and we make ATP. Remember that ATP is energy. And living organisms need to get energy. But sometimes you have organisms that live in areas that don't have oxygen. Not every place on Earth has oxygen. There's tons of places that are lacking in oxygen. Now, what these organisms do is instead of using oxygen, they're going to use a different gas. Sometimes it's carbon dioxide. Sometimes it's sulfur dioxide. Essentially, they use some other molecule that has oxygen in it, and then within that organism, they'll kind of break out that oxygen. So they don't use oxygen, they use some other gas instead. And because they're using some other gas, they actually don't produce carbon dioxide. Instead, they're going to create methane. So these are organisms, and by organisms, I'm really referring to bacteria. It's pretty much bacteria that are able to do this anaerobic respiration. They don't have access to oxygen, so they're going to use other gases. And no matter which gas they use, the biggest thing that they're going to release is this methane gas. Now, we as humans can contribute to methane a couple different ways, and most of it is kind of indirectly. So, for example, cows. Cows have an incredibly long digestive system. And because of this, there's not that much oxygen in it. There's oxygen at the front and near the rear, but everything in between is kind of lacking in that oxygen. So there are tons of bacteria, just like there's tons of bacteria in our intestines, tons of bacteria in the cow's intestines, but they're designed and they're adapted to these low or no oxygen conditions. Instead, they're going to use other gases and they're going to create that methane. Now, what cows literally do, if you've ever been around a cow, you probably know this, they burp a lot and they fart a lot. And when they're burping and when they're farting, they're releasing methane. And they're releasing lots of methane. When you and I burp and fart, we're really releasing carbon dioxide and nitrogen. But cows, it's methane. So huge, huge source of methane. But cows have always existed. They've always done this. So why am I even mentioning it? Well, there are a lot more cows now than there used to be. We as humans are creating cows, so to speak. There are a lot more cows because humans use cows. Whether we're using dairy cows, whether we're using cows for meat, we use cows. And there's a lot more cows that exist because of us. And because there's a lot more cows that exist, that means there's a lot more methane being produced. And again, that's kind of our fault because we're the ones who made more and more cows. The other issue, something else we really love to eat, is rice. Rice is grown, and you can see that in this image, rice is grown underwater. Or I really should say it's grown above water, but there's usually a couple inches of water at the base of a rice plant. Well, this is really still water. If you've ever had a fish tank, you know that you can't just put it in water. Like, you need to be giving it oxygen. Well, that's the thing here, is that this water's not doing anything. It's not moving. It's not getting oxygenated. And so what happens is there's a lot of bacteria that live here that don't have access to oxygen. So they start undergoing anaerobic respiration. They're going to grab some other gas. They're going to strip the oxygens from it and they're going to process it in that anaerobic respiration. And then they're going to release this methane. So rice paddy is a huge, huge place for methane production. Kind of like cows, this isn't directly our fault. like we can't control that rice does this. We can't control the water in it. But there's a lot more rice being grown because of humans. If there wasn't humans around, this would not be as big of a problem. Sure, there'd be some methane, but not nearly as much as compared to our rice cultivation practices. And then finally, methane stuck in the permafrost, in the tundra, so really in the coldest places on Earth. And so let me kind of demonstrate or draw what I mean by this. So permafrost means permanently frozen soil. So perma and then frost. Permafrost is permanently frozen soil. This is found in the coldest regions of our Earth, particularly think of the Arctic. The Arctic is covered in permafrost. Even if that ground is exposed and you see mosses or lichens or something, the soil itself is frozen. There's nothing coming in and coming out. Now, because there's nothing coming in and coming out, so here's the oxygen in our atmosphere, and typically oxygen tries to go into the soil because there's lots of little holes in soil, but because it's frozen, oxygen isn't going into the soil. Now within the soil, you've got lots of little bacteria, microscopic bacteria, and they need energy just like the rest of us. And so the way they get that energy is these guys are doing anaerobic respiration. They're going to use some other gas that exists down there, maybe carbon dioxide, maybe sulfur dioxide, maybe something else. And when they use it, they're going to create that methane. So methane is CH4, but I'll write methane here as well. But the methane, being a gas, wants to go up, it wants to go into the atmosphere, but it can't. Just the same reason oxygen can't come into the soil, methane and other gases can't leave the soil. It's frozen, it's stuck. And so what happens is you get these little, let me use a different color here. You get these little kind of air bubbles. So little air bubbles of methane. And this is a completely natural process. This has been happening way before humans were around. We are not doing anything to accelerate this, to change this. This is something that always has been and always will be. However, our issue is this permafrost isn't really permafrost anymore. Because climate change has already been happening, permafrost around the world has started to thaw, has started to melt, so to speak. That soil is becoming accessible. And because that soil is becoming accessible, this methane can escape. This methane can now go back into the atmosphere. Oxygen can also enter, but okay, that's great that it can enter, but that's not the problem. The problem is this methane. This problem was methane was stuck in the soil, and it was there for safekeeping. It wasn't contributing to greenhouse gases. It wasn't contributing to climate change because it was in the soil. It's not anymore. Instead, it's leaving the soil. It's entering the atmosphere. And because methane's a greenhouse gas, it's actually making it warmer. And because it's making it warmer, more permafrost is melting. And because more permafrost is melting, more CH4 is entering the atmosphere, and the cycle goes around and around and around. And this is already happening. In Russia, they're actually selling off permafrost to people. So currently, just Russia owns the permafrost. Like, it's not a person that owns it, and it's not divided up because no one wants to live there. There's nothing you can do. You can't even build there because you can't get structures anchored into the ground. But they are actually selling, same with Canada as well, they are selling the permafrost because they're already seeing this. They actually have more access to land now. So that's kind of cool. But, the whole global warming thing, that's kind of not so great. But this is what I mean when I say that the permafrost is thawing and we're releasing methane this way. So again, this methane was going to be created with or without us, but because of us, it's now being released into the atmosphere. So before we move on, I do have a video that kind of shows this methane in the permafrost. It's a couple of researchers, I think they're in Siberia, and essentially you can actually see these big bubbles of methane like right on the surface of this permafrost, and they kind of show you that it's methane because they stab the bubbles and they light them on fire, which you can't do with regular air. Now, although they are stabbing those bubbles, I mean, you can see it's really not that difficult, and that the ice in the soil that they're stuck in was going to melt anyway. But it wasn't like this before. So pause here, take a look at this video, and then come on back. So just as a recap, the two major greenhouse gases we're going to be exploring are carbon dioxide and methane. Methane is a lot more potent than carbon dioxide though. Despite the fact that it's a lot more potent, we're really not releasing as much of it as we are compared to carbon dioxide. Also, we haven't really changed how much methane we're releasing. It's been pretty constant over the past few decades, whereas carbon dioxide is increasing a lot. Our carbon dioxide is coming from fossil fuels, it's coming from deforestation, excuse me, whereas methane is coming from that anaerobic respiration. Whether it's anaerobic respiration happening in our cows or in our rice paddies, or if it's anaerobic respiration that's always been happening in the tundra, but is now being released, that methane is being released into our atmosphere. So the next video we're going to take a look at is we're going to take a look at some trends around the world and kind of see who our biggest culprits are.